Hello, guys, and welcome to the session for today. It's my pleasure to be a moderator for this session. Let me start by introducing myself. I am Fatima Dirani from Lebanon. I have done Masters in Production Enhancement from St. Petersburg Mining University, Russia. Today, we have a very interesting lecture on visual data analysis. The instructor who is joining us today is Dr. Yasser Shaib, a very high esteemed and skillful professor. Before proceeding to the session, I want to give some important tips, so please listen carefully. For your questions, use the Q&A section. Avoid chats while attending the webinar as it can divert your attention from the lecture. And feel free to ask anything related to the topic. I would like to welcome our respected speaker for today, Dr. Yasser Shaib. Dr. Yasser Shaib graduated from Cairo University in 1990 with a degree in mining engineering and got his PhD from Nancy School of Mines in France. The teaching and research activities of Dr. Yasser Shaib mainly focuses on rock mechanics, data analysis, risk assessment, and project management. Dr. Yasser Shaib has a passion for knowledge dissemination in disparate fields of sciences, and currently he is a professor of engineering at the American University in Cairo. Let's warmly welcome our honorable speaker, Dr. Yasser Shaib. Please continue. The session is over to you.
Thank you very much, Fatima, for this introduction. Thank you very much, everyone, for attending this third session on quantitative data analysis. Today we're going to work a little bit more in a practical terms. I will not have a proper presentation, like a PowerPoint presentation to show you today, but I thought that maybe since this course is about data analysis, so let's do some data analysis. Let's do something practical, and I will walk you through some of the tools that I use every day for my work, actually. Well, since most of you are from petroleum engineering background or petroleum and earth sciences, I would say, background, I thought about bringing some of the databases that I used to work with and show you maybe the problems that we have in the data. Remember last time we spoke about data preparation, we spoke about data visualization, we spoke about different aspects. So today maybe we can speak about how to deal with real data that we have. The data that I'm presenting here in front of you is real data from a real field. And I have to confess that since I'm not a petroleum engineer, and I don't have a petroleum engineering background, so maybe some of the variables that we have here or some of the parameters that we have here, I don't know them, and maybe you know them better than I do. But I will walk you through those data from a data analysis perspective. And of course, as I also mentioned last time in the last webinar or lecture, if you will go online and type something like data for petroleum engineering or data for hydrologic fracturing or data for water injection in petroleum engineering or whatever, and or maybe in your school you'll put your hands on some of the data that some of the researchers are working on, and all of this is of course permitted, and you can look at it. Actually, I will share with you my my whole desktop because I'm opening a lot of files, and I want you to see those files. So yes, I'll share my desktop. Okay, this is my desktop. So this is the data file, for example, and as we spoke last time, this is what I will call the data matrix. And the data matrix, as we spoke last time, is composed of parameters. We call them variables. Those are on the columns, and lines of data, what we call them cases, or what we call them individuals, whatever the case is. And then the real data is put here. And usually this data, this data matrix, the number of columns is more than the number of rows. I don't know if this is applicable in this case or not. Probably not, because we have here until AM, which is like maybe 35 variables, and we have here only 31 individuals. But anyway, this is just to show you the data, and then we can look into the titles of of the uh, of the variables. And obviously here, O/G could mean oil or gas. So there is a code here. There is something, a variable called drain area. There's a variable called drainage radius, casing diameter, well bore radius, permeability height, or draining volume for whatever. I mean, names for these variables. And then you have here the units. So this is with acre. This is foot square. This is inch, foot cubic, or foot cubic feet, and whatever. This is foot per square root of a minute. And you have the numbers here. And even the numbers, even the data itself is variable. It's very much variable in display. So here you have a number that is 4 characters behind the comma. Here you have a number. Here you have a scientific number, 1.87 times 10. With eight zeros after the 10, and then here you have 51.24, 0.29, and 7, and so on. And remember, last time we spoke about the types of data, the types of variables that we have. We spoke about having quantitative variables and qualitative variables. And in quantitative variables, we had continuous variables, which is, I would imagine that it could be this one, like drainage radius, could be anything. I would imagine that this is a continuous variable. It could be 1097.216663 or 1147.70 something. Then you have discrete data, which is, it could not be divided into 2. And I would imagine here something like this one. So you have here 200 feet, 50 feet, 55, 51, 35. There is nothing like 35.5 or 35.6 or so on and so forth. Then you have also here in this data a qualitative variable, which is AGEP1, AGEP2, BP1, BP2, BP3. Probably this is the name of the field. So it's a qualitative variable anyway. And then you have also some missing data. We spoke about missing data last time. So this is not available, not available, not available, not available. And not available does not mean that it's a bad thing or a good thing. It means that maybe we forgot to put the number here. Maybe the sensor that is capturing the data was in a status of failure here, so we didn't have anything. Well, we don't know. I mean, I actually don't know for this one. But anyway, this is the kind of data that we have. Let me show you another file that I have here, and I have here a file called DeepStar. I think it's the name of the company that we were working with at that time. And you have here a sheet called field, sheet called reservoir, sheet called well, and in every one of them there is also different types of data that you can look at: lease, well, first production, last production. This is obviously a date. This is also a date. Cumulative oil, cumulative gas, PI. I don't know what PI is. Peak oil ratio, peak gas ratio, peak equivalent ratio, date peak, drain area, oil EOR, gas EOR. I don't know what's that. Equivalent EOR. Maybe it's something that is in petroleum engineering. And then you have here field name, and you have the names of the fields, and you have here, 101 cases. And from A to T, you can count the number of the variables that we have. So this is another file. A third file that I want to show you, just as an example. I'm just showing those files as examples of types of data that we come across when we work in data analysis. So this is a third file, and then you have here a date, well, pro chance. I don't know what's pro change. I don't know what's this. OIW, no zeros. OIW 30A, field depth, preservoir, PFRAC, length, days, hours, choke, and so on and so forth. I see I'm I'm just looking into the data, and obviously there's a lot of missing data here in this file than in the others. I don't know why. I mean, I'm just making it smaller so we can see the portions of missing data. So here we have a big portion of missing data. Here we have some missing data here and there, but then everything else is maybe complete. And this is a bigger number of individuals. I think we have, yeah, we have here, yeah, I thought it's the order of thousands. Yeah, we have here something like 17,000 data points. Let me look at it again. Yes. No, I'm sorry. We have like 15,000 data points, and we have a number of variables that goes from A to AL in Excel. That this means something like, yeah, maybe 40 variables or so. So that's another file. And the last file that I have here is this one. And in this one, it's a bit special because here they have like different wells, and for every well there is a different sheet. So you have the same data, the same type of data. Here, slurry flow rate, propant concentration, treating pressure, bottom hole pressure, bottom hole temperature, static string pressure. And this is for Chev 3MI, Chev 4MI M1, and so on and so forth. Of course, from the names of maybe of the wells, you can imagine that this is maybe Chevron. But this is like the year 1999, the year 2000. This is very old data that I have, so it's irrelevant today for anything. But anyway, I mean, when they gave it to us, when the person gave this data to us, he gave it to us in this format. So he had different sheets, and now the first question that we may ask ourselves when we start preparing the data for the analysis. And remember, I spoke a little bit about the data preparation the last time, and I said that it takes something like 60 to 80% of your time of analysis to do the preparation alone. And so one of the questions that I will ask myself, do I need to work on every sheet individually, or will I put everything in one sheet, one big sheet that will contain everything about all the wells? Well, it's, I mean, it's all, I mean, all of those are possible. If I have here 2,500 data points, and here in this sheet I have, I think it would be 2,634 data points, then if I will combine all of those data of all of those wells together, then I will have a sheet that is like 10,000 or 20,000 rows or data points that are in here. It is possible that you work on that, or it is possible also that you choose that I would like to work on this well alone, and then I would like to work on this alone, and so on. But I will try to focus today on the data preparation, and I will actually use the example. Yeah, this is the last data that I had, and it's historical water injection, if I remember well. Yeah, hydrostatic head, friction pressure, estimated BHP, reservoir pressure, and cumulative injection and cumulative pressure. So this is the data about water injection, for instance. I will go to the data on, I think it was Deep Star. Yes, this data point, that is something like 102 data points. And let's try to work with this. So suppose for the moment that I would like to know, obviously I have here field names. So I have 1, 2, 3, 4, 5, 6. I mean, I have something like 6 or 7 field names that I have here in this in this sheet. Now, suppose that my objective, or what I want to do, is like, I would like to compare the data that is in field Bullwinkle to the data that is in the field Lobster. How can I do that? And let's say that I would like to compare the cumulative oil that I will get from this field to the cumulative oil that I will get from lobster. So if I would like to do this in Excel, it is possible, definitely, but sometimes you need a tool that is more, how to say, more specialized in counting, more specialized in statistics than simply Excel. In Excel, you can maybe use the function. I mean, I'll put here an insert. You can maybe use the function that's called if-s. And for those who doesn't know if-s, it's that you are asking Excel to reason to give you an answer about a special condition. So you'll give it a logical test, as it's written here, and then the value of this logical test is true, and the value if this logical test is false. And the difference between if and if-s in Excel is that you can put here multiple multiple choices. Like I would like to make this test on 2 or 3 or 4 categories, not only one condition. Sorry, on 2 or 3 or 4 conditions, not only one condition. In Excel also we have another function called count if. So I can say count if, and I can say here, and I have to give it a criteria. I can ask him count the number of rows where you have the field name called bullwinkle or lobster or whatever. There is also another function called count if-s with an s, which means that you can count with different conditions, not only one condition, not only one if. I mean, those are tools that exist in Excel. But suppose that I would like to draw two variables against each other. I will go, for example, I would like to draw cumulative oil against cumulative gas, just to show for one reason or another that I would like to draw this. In Excel, it's very easy that I would say insert, and then I would say here, I will go here to this chart, which is called XY scatter. And I will tell him, well, this is the kind of scatter plot that I would like to draw. And here he has chosen actually a specific type of data to draw it. I will just erase this one. I don't like this one. And I will choose my data variable. So I would like to draw a scatter plot with those two variables alone. And here I will go to insert again, and then this one, and this is it. This is cumulative gas against cumulative oil, and those are the points. And well, when you draw this on a line, you have some types of information. I would say that generally speaking, when the cumulative, because it's the cumulative oil on the x-axis and it's the cumulative gas on the y-axis. So usually I would say, generally speaking, when the cumulative oil increases, the cumulative gas increases. There is a correlation here. I mean, I can draw even a line here. And you can ask Excel actually to draw a trend line, what we call a trend line for this data. Nevertheless, you have something here, which I would call an outlier, as we spoke about outliers last time. This is a data point where you have 18 cumulative oil, while everything else is like 14 and less. And then the cumulative gas is like 140, while everything else in cumulative gas is like 60 or maybe less. And of course, the first question that we ask ourselves is this data erroneous? I mean, is it a mistake? Is this point a mistaken point? I mean, does it exist 142.9? Does this exist really? Or it's an outlier? So first way to treat an outlier is to ask the question, is it really an outlier, or it's just a typo? Maybe the person who's typing the data typed 142.9 instead of typing 14.29, for example. It could happen. or 1.8, sorry, or 18.6 instead of 1.8. It could happen as well. But once we are sure that this data is real, this point is real, we start asking the question, what happened in this point? And in Excel, actually, we have a problem because we need to know where is this point, and we don't have any way, or maybe in advanced Excel we can have that, but we don't have any specific way to tell us where is this point, which point is this point. So we have to go and to find this data point where we have a cumulative gas of 140. So I can do this by maybe going here and doing a filter on the data. I have to delete this. Sorry. So yes, I will filter the data and I will tell, let's sort this cumulative gas descending. So the 142 appears here. So this is the point of the 142.9. And then I will start focusing on this point and start analyzing it bit by bit. So why is it 142.9? Why is this point very special? It's in a field called Ram-Powell. Nevertheless, this specifically Ram-Powell field has other points where the data is normal, or I would say logic, or I would say within the usual numbers. So this is a way to start to look into the data and to prepare the data and to be aware of the data. Actually, if I would like to see the distribution of remember we spoke last time about the statistical distribution of the data, and I actually asked you to go online and to look into different distributions of the data. Here we have, if I would like to see the cumulative oil distribution, this variable, how is it distributed, starting from 0, ending by 20, for example. I would like to draw a histogram for this for this data. How can I do this? In Excel, it is possible, but it is still very difficult to be done. I mean, it takes a lot of time. It takes a lot of effort to do this. For that, I would really take you to another tool that I asked you actually in the first lecture to look at, which is called R and RStudio. And in the world that we are living in today, let me open up a web browser. And I'll show you how to find it again. Yes, so this is Safari. It's like any other thing. And I will type here R, only the letter R. And I'll search for it. And here it brings me back, the first link that it brings me back, the R project for statistical computing. I'll click here and it will take me to this page, which says the R project for statistical computing, and you can read about R. And R is actually a tool that does a lot of statistical analysis. And the advantage, as mentioned before, is that R is completely free. It's an openware. So it's a free software environment that anybody can use, anybody can download, and you can download it on your computer, you can run it on your computer. You have no problem in doing this. Here I go to the usual different servers that I have that have it on it, and I have here download R for Linux, download R for Mac OS, download R for Windows. You can also download it for other platforms if you want afterwards. But I would presume that most of us in this world today, we are really concerned with those three platforms: Linux, Mac, like myself, or Windows, like many others. You just click here; it will download the software to your computer. You can download it and install it and start running it. But just before running it, because R as a software, I can run it for you. I can show R running. Yes, there it is. And I mean, you need to know a lot of scripts in order to work with R. So this is why a lot of people around the world have invented a lot of geographical interface for that tool. And the one that I like, I mean, there's definitely a lot of environments for R. The one that I like is called RStudio. So RStudio. again in the search engine. And here it goes, RStudio. It's an open source software as well, and you can download it also for free, and you can use it for free. Yes, RStudio Desktop, it's here. And then download RStudio Desktop. It's, as I said before, it's free. You just have to download it and choose what you want. Of course, there are different other versions that are not free, that are paid for, but those are for maybe for professional use, for commercial license, like it's written here. But for us, for the academic usage, if you click on download, you will also be directed to RStudio for Mac, or RStudio for Windows, or for Ubuntu, or for, I think Linux would be somewhere here, Fedora, and so on. Anyway, please go online, download RStudio, and let's run it, and let's see how does it look like. This is RStudio when you open it, and here you have 4 smaller windows. This is the window where you input your data. This is the window which we call the console, which you will get results of your questions. This is the window on the top right where you have the environment that you are working with. When you store variables, for example, when you store data sets, for example, into variables, this is where you see it. And here is where you see your output as plots, where you see your files, where you see a lot of things. So this is like the viewer of the output, and here is the text output that you get. R is very simple. It's like a graphical, it's like a mathematical interface, and probably I've done this last time. It's, I mean, if I type here 1 + 1, and if I press enter, it will do nothing. So I have to come back to 1 + 1, and I say run, and I will get the answer here below. So 1 + 1 is equal to 2, and that's an answer that we all, of course, we all know. I can say 2 to the power of 5, and then I say run as well, and 2 to the power of 5 is 32. So that's also a number that I know. But instead of going and clicking on run here, you can also, I don't know in Windows, but I think in Windows it will be Shift Enter. Because, or Control Enter, because in Mac it's Command Enter. So it Windows it should be Control Enter. So you click on Control Enter instead of clicking on Run. Now I'll show you just very rapidly some tips of this environment. I can store everything in variables. So I can say yes sir is equal to 2 to the power of 5. Sorry, to the power of 5. Okay, Control Enter, and you realize on the right hand side here you have a variable. This is the global environment, as I told you before. You have here a variable that is stored in the system that's called Yasser is equal to 32, and I have here Yasser is equal to the power of 5. Now afterwards I can say I'm asking the computer Yasser plus 5. What's the value of Yasser plus 5? And it will give me a 37. And it goes like this. If you've ever worked with Mathematica, or if you have worked with MATLAB before, you will be probably more, I mean, acquainted of those things. I mean, it's simply like any other mathematical or statistical environment. The difference is that in R, there are a lot of statistical functions that are defined by default. So if I want to do a histogram, for example, in Excel, I will have to do a procedure in order to develop a histogram. Here in R, you just type hist, and then give the variable, and it will draw a histogram. Or we have also scatter. And you open a parenthesis, you close the parenthesis, and then you put the X and the Y, and then it will draw a scatter plot. You can draw a bar chart or a bar plot. We call it a bar plot. Okay. a bar plot, and it will do it. I mean, there's a lot. I mean, there is like hundreds of thousands of functions that are out there that you can use completely directly. Just you need to know the syntax of those functions. And in order to know the syntax of those functions, it's quite easy. You just go to help here, and you just type the name of the function that you want to use. So, for example, I mean, of course, it's usually will remember the last session that you were working with, and obviously the last session when I was working with our studio, I was working on neural networks, which is something that we will reach out, maybe not next time, maybe the last session. So I was inquiring about the neural networks, and it gave me some of the syntax of the how to develop neural networks under R. So if I write here bar plot and ask about it, it will tell you that there is this, there is that, maybe yes, bar plot, and this is the usage of the bar plot and how to use it, how to put the syntax. Everything is put here. Over and above, in R, there is something that is very interesting, and it shows this nature of being collaborative work and free software. It's what we call the packages. So if you go to the internet and type, for example, R packages, you will find a huge list of packages, which you can think of as tools that you can dedicate. This is a course actually. I didn't go to the right place. Welcome. Yes, I think this is it. CRAN packages. Yes, CRAN packages by name. So you can see here there's all of those are packages for to be used with R, and all of those are very specific. I mean, if you look into this one, it's high dimensional inference with a penalized score tests. Why not? Draws diagram useful for checking latent scales. Scroll down, handling missing values with multivariate data analysis. This is the function, or this is the package that you need to work. I would say that almost every statistical function, every data analysis, every quantitative data analysis function that we use, that we need, that we know, there is a package for it. And you can install packages and you can activate them. I mean, those are the packages that I have installed myself on my computer. All of them are here. And the ones that have a check sign are the ones that are actually activated. The others are not the one that I don't want them now. I don't want them to be activated now, but maybe in the future I will activate one or two of them. So it depends on the environment, depends on what I want to do. And of course, there are specific packages for graphics, specific packages called ggplot2. This is one of the very famous and known packages that are in R that you need also to maybe to download. Now, the way to download or to install a package is the following. You just go to tools and then install packages, and just not type the name of the package here. So I'll say ggplot2, for example. You will find that it brings you the name, and you just install it. And of course, it says do you want to restart? It's updating the package. I mean, it will update the package as well, and it will start the R session and everything. So now I have it here. I have it installed, and I can run it. You will see here. I mean, my R is working, is installing downloading something from the internet and installing it on my computer. Now I have it, and it is in the right place, and it is installed. Now I go to ggplot. I check on it to make it activated. I will click on ggplot2 just to see its contents. So this is the contents. Those are all the functions that are inside this package of ggplot, and you have here a lot of functions that are in here. I know that it usually takes a whole course to tell people how to use R, but the objective of this lecture today, or this webinar today, is just to give you a very brief and rapid introduction to this tool, I hope that you will be that you will download it and that you will work with it. And if you have any questions, just come back and ask me. And of course, there's a lot of information, a lot of resources on the internet, a lot of courses specific for R, and a lot of also free courses and free books that you can download in order to learn this marvelous tool. If ever you will be interested to work with data analysis in the future, R is one of the essential tools that you need to have. Now, let's import the data that I had in my Excel file. Remember this data, and let's try to work with it. And in order to do that, I need to save this file in a place that I know. So I will simply go back to Excel, and I'll say save as, and I will save this file on my desktop. Okay, so it's called Deep Star Data Revision. I will call it only simply Deep Star XLS, and save, and it is already on my desktop. Now I go to R, and I need here to import this data set. And you have here different tools to import the data set. You have a function called read Excel. Read Excel, yes, Excel. You can Excel S, I think that's the name of the function, or you can do here import data set. You have here a function, or you can go to files and browse your computer. Actually, this is a browser of your computer. So I go here to my browser, and I'll go up. This is my desktop. Desktop should be somewhere here. Yes, this is the desktop, my desktop. Yes. Okay, go ahead. And this is all the files that are on my desktop. And remember, the name of the file was Deep Star. Apparently, the names are sorted in a descending order. So I go to D. Yeah, this is the file. So I can simply click on that file, click here, and you have here view file or import dataset. It's the same as if I would have clicked on import dataset here. It's the same if I would have knew the syntax, and I would have written the syntax on the computer. I will go to import dataset. Okay, import dataset, and here you have a browser, and here it says the name is called Deep Star, and this is actually the syntax that you need to write. The first thing that I have here is this. Actually, it opened the first sheet on the data. So remember that my Excel file here, it had, where is it? Star, I think, yes, this is Deep Star. It has three sheets. One of them is called field, one of them is called reservoir, and one of them is called well. Now, what R did is that it opened the first data sheet that I have here. Now, I wanted to open actually the other sheet. So I have two options here. Either to change the syntax, if I know the syntax, and ask it to import only or to review the sheet that is called wells, or I can simply just press on cancel here and go back to my Excel and go to Deep Star and simply delete field. So I delete this sheet. I will delete this sheet, and I have only one sheet in my file, and I'll save it again, and I'll go back to R, and I will click here on Deep Star. It will ask me the same question, import dataset, and here it will show me the dataset that I have in my sheet called well. I'm doing all of this, and I'm going back and forth from Excel to here to back and forth, and showing you some problems, showing you some examples, showing you what's happening. Actually, I'm doing this on purpose because I'm trying to show you that data preparation takes a lot of time, and I come back and insist on that. Until now, we didn't do any data analysis. We are only opening files. We are only importing our database into the software. Maybe you can think of it as you're wasting our time, or we are wasting our time. Why do we do this? Just give us the right path and that's it. And I will tell you from now, this is not what will happen when you start working with real data. When you work with real data, you need to do all of that. And probably you will come back afterwards and do something else. Now let's look into this data that is about to be imported into R. Now he said that there is a variable, a parameter called f name, and it's a character. Okay, yes, it's a character. FA break, if area break, bulk or whatever, it's a character as well. Reservoir, it's a character. Facies, that's also a character. Fluid, that's character. Lease, that's character. Well, that's a character. And then comes this one. This one, for us, for me, I understand it as a date. It's obviously a date, 1998, 0301. But R understands this as a double, as a character. So I will tell him, no, it's not. It's actually a date. So you need to tell him, you need to specify that this is a date. It's the same for the last period. This is a date. And you will realize here below that it changes the syntax that you will write your thing. So last period is a date, first period is a date, cumulative oil is a double, okay. This is pi is a double as well. This is a number, a number, a number. All of those are number. I have no problem with this. And then it asks me a very, very, very important question. What is the characters that you are using for missing data? Do you have any missing data in your data? And if you have any missing data, did you give it any specific character? So I'll go back to Excel in order to look into this problem, because I didn't look into it. Did I put anything here in those missing data to signify that it is a missing data, or I've just left it blank? So for the moment, I've just left it blank, but I think in one of the files that I was opening, yes, in this file, for example, it was written NA. So NA here means that this is a missing data. So this is where you need, when you work with R, to come back and tell R that my symbol for missing data is NA. I worked at some point of time with a data file, and we actually didn't want to put blank in the file because it caused us some problems, and we didn't want to put any characters because it would also destabilize, I would say, the system that we were working with. And the way that we came up across in order to signify that there is a missing data was to code it. So we invented, I invented a code called 9999. And wherever there is a missing data, I will replace it by 9999. And I will just leave it like that. So I mean, the computer later on, or I can understand later on that this is a code that I'm putting for the missing data. So you can go back now to R, and I will not tell him anything. I mean, for me, the missing data is missing data. Do you have a maximum number of rows that you would like to take? Does the first row contain the names? Yes. Data viewer is here, and the sheet is default. Oh yeah, I could have done this the last time I chose the field that is called well. And once I'm satisfied with what I see here in front of me, I will just import it. And here the last question that it asks me is the name of the variable that I will use in order to store this data. So I will store this data, this whole data set, this whole data matrix. I will store it in a variable called yeser. I'm very much biased towards my name. Anyway, okay, so I will have a variable called yeser that contains everything that is in here. I will say, I'll just click on import, and I will come back to RStudio. And here first thing to observe is that on the right hand side here, you have, it tells me that there is now in the system a variable called Yasser, and it contains 101 observations and 20 variables. So automatically it counted the number of the variables. Here is the data that I have. Can go right and left, up and down to look at it. And you have here a sheet, a kind of a sheet like Excel with the name Yasser. And then you have here below, it says that I have imported all of this. I have read the file Excel, and I have imported into the variable called Yasser. And I'm issuing you a warning. Take care, because there is like 50 or more warnings that I would like to tell you about. There's a lot of warnings that I have here. Probably those warnings will be that there is a lot of missing data here, there is a lot of missing data there. And of course, as he says here, you can use this function, warnings with an S, open parentheses, close parentheses, and type it in order to show you that. Where is the file that I was working with? It's here. So this is the one that I have with 1+1. So if I type here warnings, open parentheses, close parentheses, and control enter or command enter on Mac, and it will tell me, you see, you have here a lot of warnings that is giving me. And he says, when I read the function, the sheet executing data, it has got on, I mean, it expected something, but it got something different. I will not get into those details now. Anyway, I have here the names of the variables, or I can go to Yasser and know the name of the variables, and I have it here. If I want to, as I said before, I mean, this was the start. I want to draw a histogram for the for this variable, peak equivalent RT. So what I will do is that I will write here the function called hist, and I will open a parentheses, and the data that I'm trying to draw as an histogram is contained in the variable called Yasser. And the way to tell R that I'm looking into one of the variables, not everything. Suppose that I will do hist Yasser. It will tell me I cannot understand, because Yasser is not a variable. It's not a numerical variable. It's a data. So I have to specify the name of the data that I would work with, and the way to specify it is to have the $sign here. So when you put the $sign here, it will bring you a pull-down menu where you can have all the fields that you have in my data set or in my data matrix. So for example, I would like to draw a histogram of peak oil ratio. Okay, I'll just stop here, control enter, and you have the histogram of this variable that appears here. Maybe it took us a lot of time to learn, to import, to bring the data into R. Maybe you would have said, well, you know, the time that I have took in order to import the data here and to save it and to manipulate it, it would have been maybe much less time to work in Excel and produce a histogram. Maybe that's true. But remember that you have imported the data now once, and you can work with it multiple of times. You can do a lot of data with it. So that's, of course, an advantage. Let's try another variable, hist, open parentheses, and I would say yes, sir, and $sign, and lease. And it says I cannot do that, because lease is not a numerical variable. I mean, let's look at lease here. So you see here, lease is like a character. It's not a numerical variable. So you cannot do that. In order to do that, you have to convert it into a character. Now let's do a scatter plot. Yes, sir. $sign of what? Cumulative oil comma, tester, $, cumulative gas, as the one that we've done in Excel. Wow, didn't produce anything, and it told me scatter. I mean, I don't know this function. What is this function? Well, I want to draw a scatter plot. How can I do that? I'll go to help, and in my help, I will write, sorry, I have a lot of windows open. I'll say here scatter plot. We have scatter plot that is in function called, there's nothing called scatter plot. Wow. How can I do that? That's a problem. And I don't know. I don't know what's the function to do that. Let's go to Google, our friend. I would say scatter plot in R. Scatter plot in R. And the function is plot. It's simply plot. It's not scatter plot. I mean, I made a mistake. Again, I'm doing this on purpose. I'm showing you how to find the information. Now, I don't know how to do scatter plot. I thought that it's a scatter and then the name of the variables, but I tried it and it gave me an error and it didn't work. So, and I discovered by going to Google and asked Google that the answer is plot. So it's simply plot, and I will copy everything that's here. I'll just copy it here. And I have the same graph that is as the graph that I had on Excel. Now, if I want to do a bar chart, a bar plot, I can do it this way. If I want, I mean, there is a huge, I mean, large number, very large number of functions that you can use in order to produce graphics in R. I'll go back here and type bar plot in R. And bar plot in R is called bar plot, and you open and you close. And of course, if you click on this link, you will find a lot more information about how to draw a bar plot like this, how to do this, how to do that. I'm really very much interested in showing you how to do such thing and search for it. I mean, this is the way that we learn, that we all learn. We don't do things by the first time. I didn't learn even R. I mean, I spent something like 2 years in order to learn R and to be perfect in it. Or, I mean, I would say definitely less than perfect in it. But I spent like 2 years learning this tool called R. Now, the way that I did it is that I made mistakes. I corrected my mistakes. I spent a lot of time preparing my data. I spent a lot of time doing this. I spent a lot of time doing that. And then finally, at the end, you get to find information. The other tool that we can use in order to do rapidly, maybe more rapidly than in R, graphical data analysis is Tableau, which is also one of the tools that are available. Unfortunately, it's not for free. But if you are a student and you have an email with a domain name that is called .edu in it, you can have the Tableau for free. I mean, this is legal. It's not. I mean, you can have this data. And this, remember, this is the tool that I used last time in order to show you the analysis of your data. Now, let's import the same data of this file DeepStar and try to work with it. So when you open Tableau, you have like connect. I go to Microsoft Excel, and my file is on desktop. On the desktop, it's called DeepStar. Open it, and it will show me now a preview of my data with some questions. So it understands that this is a date, that this is also last production. I will have to tell it that it is also a date. I can describe it. I can change it to be a date. I have to click here and say it's date and time. actually. So this is date and time, this is date and time, and so on. And then Tableau is much simpler. If I would like to draw, what was it? The oil and the gas, okay. Cumulative oil and cumulative gas. And it's not the sum, it's a dimension, and this is also a dimension. And you have maybe not the same because it's inverted. And yeah, yes, I mean, this is the graph that we had in Excel, here in Tableau, that we had in R, here down below. So it's the same graph done using 3 different tools. You can have it in Excel, you can have it in Tableau, and you can of course have it in R. Well, every software has, or every tool has its own advantages and disadvantages. I would not advise you to use Excel for graphical data analysis. Simple graphs, pie chart, scatter plots, yes. But whenever you go outside this circle of doing simple graphs, you want to do something more into deep, you definitely need a different tool, you definitely powerful tool. And I would here advise R as well, for me at least. It's simple because you write syntax and you produce things. Maybe you need to memorize the syntax in your head, but it's free. While on the other hand, if you have Tableau, or if you have access to Tableau, you can also do a lot of things with Tableau. It's more beautiful, I would say. You can produce much prettier graphs in very less time, and the result, as you see here, is the same. I mean, here this graph or that graph or the graph that we had in Excel. Where was it? Oh yes, we erased it actually. If I can Control Z, Control Z, Control Z. No, I'm not able to come back to it. But anyway, it was the same graph. We had some points. Let's go to Tableau. We had some points here, and then we had an outlier here. And maybe here in Tableau we can identify this point, or maybe in R we can identify this point. But at the end of the day, the result is the same. Is that we have data. We need to draw this data on a vertical and horizontal axes and see how this data is being distributed. And I'm sure that you as mining engineers, or sorry, as a petroleum engineers, as a geological engineer, as people who are, let's say, professional in petroleum engineering or petroleum production, you can have a lot of meanings for those data. I mean, when you see a point like this, for me, it's only a point where you have cumulative oil and cumulative gas. That's it. But definitely, when you see a point like this, you have a different reason. You have a different way to reason about it. And this is what makes it a collaborative work. I mean, as I said at the very first lecture, a guy like me will have the data, will analyze it, will produce a lot of outputs. But you as a content specialist, as someone who understands this domain, you will come back and tell me, no, this doesn't make sense. Oh, yes. You know what? It makes sense. You know what? This is new. You know what? This is something unusual that we didn't see before. And this information I will not get. I personally, I will not get it, but you will be able to get it. So this is the link, I would say, between someone who's working in data analysis, like myself, and someone who's working in a specific domain. And as I said at the beginning, I worked with people in petroleum engineering, I worked with people in financial stock markets, I worked with people in health sector, and all the time I was producing information, I was producing graphs like this, and I would leave it up to the specialist in the field to tell me what does it mean. And this what makes it, why, I mean, this is to answer the question, why is it important for a petroleum engineer to learn data analysis? Because if you will learn data analysis, you will not, you will understand the data more than someone who didn't learn anything about data analysis. Now, what I will ask you to do, as last time I asked you to go to the internet and search for distribution, statistical distribution, maybe mean and median and mode and so on. I will ask you also to do the same this time. Please go to the internet, please download R, please download R Studio, please try to do some basic statistics with it. I mean, you can, like, we can go back to R and say mean of the variable that is called yes sir string cumulative oil. Yes. What's the mean of that variable? The mean of that variable and the mean value for the cumulative oil is 4.108795. What's the mean for cumulative gas? It's 7.5. Physically, what does that mean? I mean, does it have a physical mean? Does it have something? Does that signify something? That the mean here is 7 and the mean here is 4? Does it mean anything for you physically? I mean, forget about data, forget about me, forget about yes, forget about anything. Just you as a domain person. Does it mean something to you? This is what we are actually interested in. There is a huge library of graphs that we can do with this data. And I can show you box and whiskers graph, bar plot, box plot, graphic plot, daisy plots, circular plots, a lot of those plots. But if I don't understand the data, if you don't tell me what to do, if you don't tell me what you expect, this is where I will fail. And as you've seen now, it took us something like 10-15 minutes to prepare the data, while it takes us like 1 second to type mean Yasser com oil and then control enter, and then voila, we have the data, we have the answer, and that's it. So again, what I will ask you to do this time is to go to the internet, download R Studio, try to get access to Tableau if you have an email. I mean, I presume that most of you are doing studies and you have your official email from your school or your university, so you have a .edu domain email, so you can ask for, I mean, usually when you download Tableau, it will give you like 14 days of trial period. And during those 14 days, you can claim your free copy. So please do that and try to analyze any type of data that you have that you can see in your at your school, at your or even at home, or grab something from the internet and try to play with it. And I will see you the next time with more of descriptive analysis of data, how to describe the data, how this 20 variables we can describe them, or we can analyze them, all of them at once. How can we do that? So this is something that we will discuss next Tuesday when we come back. It's beyond the hour and 3 minutes now that since we've started, and I will stop here and I will see you next Tuesday. Fatima?
Okay, so thank you so much, Dr. Yasser, for this amazing lecture. And now we have to move to questions. So the first question, what is your opinion in JMP statistical software?
JMP statistical software? What's that?
JMP. So
JMP.
That's an abbreviation of something. Okay, let's
software. Let's search for it.
Okay.
Statistical JMP software from SAS. Well. Okay. This is maybe the suite of computer statistical analysis we developed at JMP Business and SAS Institute. Okay. Well, it's any statistical analysis tool that you can have, that you can put your hands on, will definitely have the same, more or less will produce the same graphics. You can have, you can get the same output from it. Now, there is SPSS, there is SAT, there is Tata. I used to use a software called Statistica. It's now purchased by Dell. There is a Minitab as well. I mean, if you go to the internet and you will ask for statistical software, you'll find like 50 of them. that are existing in the world. And all of them will produce more or less the same thing. But what I like actually about R is that it's free. I mean, you can download it at home. Maybe someone has an access to this JMP, but maybe somebody else doesn't have an access to it. Or maybe you have an access to it at work, but then if you'd like to work with it at home, then I don't have a specific opinion on it, but I would say it's the same like any other statistical software.
Okay, thank you. The second question is, what makes R Studio better in using than Excel, which also has statistical features to use?
Well, the statistical features in Excel are very much limited. There's like 10, 15 statistical tools or statistical functions. In R, you have something like hundreds of thousands of statistical functions that you can do. I mean, in Excel, as I said before, in order to fabricate a histogram in Excel, you need to install an add-on, and then you go and then you do this and then and that and so on. But here, it's just one line of functions. So, and when we will move on for the next sessions, you will see that there are things that are done in R that definitely you cannot do in Excel, or you will spend like a year in order to program Excel to do it. So they are completely different tools.
Okay, thank you. And there's so many questions about if you can share the Excel sheets so students can do application, like use these tables.
Unfortunately, I cannot, because those are Excel sheets for data fields or wells or of oil fields and wells that I've worked on, and I don't have a permission from the owner of the study to reveal those data to give those data to anyone. I'm just using them for illustrative purpose, but you can, of course. I didn't try this before, but maybe we can try it here. We can type here data set about oil and gas. I'm sure that you see oil and gas Kaggle, oil and gas data sets and machine learning projects. 328 data sets available, oil data on data in the world. I mean, there's a lot of data that are on the internet. You just go and try to find it. It's so easy.
Okay, thank you very much, Dr. Yasser. So, guys, if you fail to catch up with our Zoom meeting, you can watch it on our YouTube channel, Petro. And please hurry up in joining our Google Classroom if you have not joined so far. You will only be notified of the quizzes and final exam once you join the Google Classroom. The link to Classroom is available on our Facebook page, Arab Oil and Gas Academy. So again, thank you, Dr. Yasser Shaib. It was an amazing session, and I'm sure everyone has learned a lot from this highly informative and interesting webinar. Hope you guys enjoyed this session. Please stay safe and see you again.
Thank you very much, and see you on Tuesday, inshallah.